Let's talk about how we're going to be able to evaluate logarithms. Now, for the most part, the logarithms that we've looked at so far have been, well, relatively easy. If you think about our logarithm with a base 3, we could have easily evaluated anything that had a base 3 number in our logarithm. For example, no problem evaluating a logarithm base 3 of 81 because we knew that 81 was the same thing as 3 to the fourth power. And so we could say, well, this is really the same thing as taking a logarithm base 3 of 3 to the fourth power, and our result is going to be equal to 4. That's no problem, but what happens if we change this number? What if it's no longer 81? What if, for example, we have something like this, the logarithm base 3 of 15? Well, this is where we need something called the change of base theorem. And we'll note right away there are no base buttons that you can use in your calculator. In other words, you can't enter in 15 and then a base 3 and then hit a log button or something like it to get this value. We have to resort to other methods. And so what we use is called the change of base theorem very easily. The change of base theorem says this. If we have fixed numbers, constants, a, b, and x is our variable, it's a, or could be a fixed number, doesn't matter, and these are all positive real numbers, and neither a nor b is equal to 1, right? Remember, that's important. Then the logarithm with base a can be converted to a logarithm of another base b as follows. And here's the main formula right here that I want you to know. It is that the logarithm base a of x is equal to the logarithm base b of x, as long as we remember to divide by the logarithm base b of a. And this is useful because your calculator has two kinds of logarithms. The first one is a logarithm base 10. So when we see logarithm of x, well, that logarithm is a base 10 logarithm, and that's this very first button up here on your calculator. Now, on the other hand, if you take a logarithm base e, which is our natural log of x, we have a button for those. The dead giveaway, of course, is the E or the 10 that you see appearing above each of those buttons. We know that these are the types of logarithms that we can evaluate them. So how can we use this change of base theorem? Well, for example, we could use the logarithm, the common logarithm base, and rewrite this as the common logarithm of 15 divided by the common logarithm of 3. We take away that base here, it's no longer a base, right? It becomes the actual argument of the logarithm. So bringing up my calculator, I'm using a Windows calculator instead of the TI calculator here. But if I use my Windows calculator, that means I'm going to take my logarithm base 10. So I'll take 15, I'll take my logarithm of that. And if I divide that by 3 and take its logarithm, you see up here on the window log base 15 divided by log base 3, I get approximately, I bring my calculator over here, 2.465. 2.465. Not too bad. Now, you could verify that this would be exactly the same thing as if we were to rewrite it in terms of a natural logarithm. So, as another example right here, let's say I wanted to evaluate the logarithm with a base 0.5 of 11. What would I get there? Well, I'm going to use my natural logarithm right here. Before I get to that, I'm going to use my natural logarithm form of this, and we can say, well, this should be, by this change of base thing, the same as the natural logarithm of 11 divided by the natural logarithm of 0.5. And let's see how that one works out here in my calculator. This is my natural log button on the Windows calculator. So I want to take the natural logarithm of 11, and I would want to divide that by the natural logarithm of 0.5. Natural logarithm of 11 divided by the natural logarithm of 0.5 comes out to be negative, approximately here we'll say negative 3.459. So let's say 3.46. Negative 3.46. So we're pretty close right here, right? Negative 3.46. If we keep this in mind, right, remember this change of base theorem allows us to evaluate these.